We have previously learned about how limestone is formed and the limestone cycle. We will now learn about the uses of limestone and its many real-life applications. Limestone is the starting material in the production of quicklime, which is calcium oxide, and slaked lime, which is calcium hydroxide, as seen in our previous lesson. There are many more uses to limestone than simply producing quicklime and slaked lime. Limestone can be used on its own. Many structures have been carved out of limestone, and many buildings have been built with mostly limestone. Some examples include the Empire State Building in New York, the United States of America, and St. Paul's Cathedral and the Houses of Parliament in London, England. If we go further back in time, the external structure of the Great Pyramid of Giza in Egypt is made of limestone, as are the walls of Machu Picchu in Peru. This goes to show that the usage of limestone as a building material is not a recent innovation. There is, however, a fairly recent major environmental issue. Acid rain is slowly eroding these and many other limestone structures. One of the acidic components of acid rain is carbonic acid. Calcium carbonate reacts with carbonic acid to give calcium hydrogen carbonate, which is soluble in water. As a result, these limestone structures erode. Limestone can be used to make other building materials, such as cement, mortar, and concrete. When limestone is crushed and heated with clay in a rotary kiln, cement is made. Cement can be mixed with sand and water to produce mortar, which is used to glue bricks together. Cement can also be mixed with sand, gravel, and water to produce concrete. Concrete, when hardened, is very strong. Pouring concrete onto steel bar structures creates reinforced concrete, which is even stronger. Limestone can even be crushed and used as an aggregate when paving roads. The term aggregate simply refers to crushed stones and minerals for construction or road building purposes. When limestone is heated with sand and sodium carbonate, certain types of glass can be made. Limestone can also be used to neutralize acidic waters in soil. This process is known as liming. We can mimic this liming process by placing some eggshells into a very dilute solution of hydrochloric acid. You can observe that the eggshells will dissolve in acid and a gas is produced. Can you write the equation for this reaction? Keep in mind that these eggshells are composed primarily of calcium carbonate. Here is a hint. It's very similar to the reaction that occurs when acid rain erodes limestone structures. Please pause and resume when ready. Calcium carbonate reacts with hydrochloric acid to give calcium chloride, carbon dioxide, and water. So calcium carbonate appears to dissolve, but calcium chloride has been formed and it is soluble in water. Note that in this reaction and in the acid rain example in the introduction, calcium carbonate reacted with acid to give carbon dioxide and water. Have a look inside your water kettle. You may see white deposits on the heating element or off-white particulates at the bottom. You may even find it around your water faucets. This is limescale caused by hard water, or water with many dissolved calcium and magnesium ions. Limescale is simply calcium carbonate, formed when these dissolved calcium ions combine with carbonate ions. Finally, as limestone is white, it can be crushed into a powder and used in paints and toothpaste as a coloring agent. In summary, there are many real-life applications and usages for limestone, including but not limited to construction materials. Limestone can be used to help pave roads and used as a component in the formation of certain types of glass and even to neutralize acidic waters in soils.